Let's pick up where we left off. The next step in this application is to check that the number of distinct host router IDs we extracted is equal to the number of distinct neighbor router IDs. This way we can check that there aren't any other routers in the OSPF network that we didn't took care of. To eliminate any duplicates from within the two lists returned by the function above, so these ones over here, we can use the set function, and we did over here. Set and set. After removing the duplicate router IDs from both lists, we can convert them back from sets to lists using the list function. So list here and list here. Finally, we should determine their length to be able to compare the number of distinct router IDs in each list. Notice that I didn't refer to the variables holding those lists. Instead, I used the name of the function and an index to reference the position of the variable within the tuple returned by our function. Remember that when returning multiple values, as we do right here, they are organized as a tuple. So, using a while true loop, right here, we are performing this verification until both lists reach the same number of distinct elements. As soon as this happens, we break out of the while loop and then store the third element returned by the function, so the OSPF list of dictionaries, in a new variable called final devices list. This is the final list of dictionaries representing all the routers in the network. Let's go ahead and print this variable using pprint. So let me uncomment this, and let's also comment the previous print statements we used. So this, and finally these two. Okay, let's save it again. Let's return to our code for the part 4 of our application. And now let's run the application one more time. So Debian 192.168.2.101 public. Let's maximize this window. Okay, so this is the final result after extracting all the values we wanted and removing all the duplicates. The last thing we are going to create is a new dictionary, neighborship_dict, which is going to be very important for generating the OSPF network topology. We need the keys in this dictionary to be tuples of two OSPF router IDs, representing the neighborships in the network. So one of these tuples should be made of 1.1.1.1 and 3.3.3.3. Another tuple should be 3.3.3.3 and 1.1.1.1, so the reverse neighborship, and so on. The values in the dictionary will be the neighbor IP addresses to which the router represented by the first router ID in the tuple can connect to the one represented by the second router ID in the tuple. This is going to help us label the links between the OSPF routers in the network. Now let's see how to obtain such a dictionary. As I said, we will create a new dictionary, empty dictionary, and store it in the neighborship_dict variable. Next, we are iterating over the list of dictionaries from earlier, and then using a nested for loop over the list of neighbor router IDs in each dictionary, getting both the index and the value of each neighbor ID in the list. The next thing to do is create the tuple of router IDs I mentioned earlier and assign it to a variable called each tuple. So this is it right here. The first element in the tuple is the host router ID of that dictionary, and the second element is one of the neighbor router IDs in the list we just traversed using the enumerate function. As I previously said, the tuples created by these for loops are going to be the keys of our new dictionary. Next, we assign a value to each of those keys, and I said we need the value to be the IP address the first router in the tuple uses to connect to the second router in the tuple. For this, we are going to use the list of neighbor IP addresses in each dictionary we are iterating over, taking into account the index of that neighbor's router ID in the list of neighbor router IDs from the same dictionary. So, for example, going to the list printed earlier, okay, R3 connects to R1 having 1.1.1.1 as a router ID using the IP address at the same index in this list, so 172.16.0.1. both being at index 2 in their lists. Now it's time to uncomment this print statement and see the result. So let's save the file and run the application one more time. Okay, let's focus on this dictionary right here. This is the dictionary we just created, neighborship dict. And it is exactly what we wanted. These are all the neighborships in our network, and they will help us show the user the information he requires through the user menu. So we have the neighborship between R1 and R3, R1 using this address to connect to R3. Then we have the neighborship between R3 and R1, and R3 uses this IP address to connect to R1, and this is valid for all the other neighborships in the network. Now let's analyze part 5 of this application, which takes care of the first two options in the user menu.